Everyone, welcome back to another video. Today we're going to look at Quartics. Now, what we learnt in cubics is almost all that we need to be able to talk about Quartics. So it's very, very, very similar, not very much difference at all. And so just to, I'm not going to cover much in this video because all the same principles apply. So again, there's three different sort of forms we can get quartics. Firstly, you can get it in turning point form, and we'll have a look at that in a second. Then factorized form, again, really nice, really simple, or general form, probably the hardest of all three, well, definitely the hardest of all three, to be able to figure out. Okay, so let's have a look at what each of these look like. So in turning point form, the quartic looks very similar to the quadratic. Okay, and so what it looks like is it's I'll just draw one. Is it comes down and it has like a real flat bottom, and that's probably draw it a little bit better than that. Okay, so it's like a quadratic, but it's like as if the bottom's sort of been squashed up. It's like quite flat at the bottom, like much more quadratic. And again, that's not a very good drawing. I need to sort of maybe exaggerate it a little bit. I'm sucking today. Anyway, you get the idea. I haven't drawn it very well, but it's got a really flat bottom, as if like someone got a parabola and they dropped it on the floor and it's squished in the bottom and it's like really flat down the bottom. So in turning point form, that's going to be the point H, K. All right, so the H there and the K there. And if A is positive, it's going to look like that, just like the parabolas. And I'll just draw it over here. And if A is negative, it's going to be upside down. Okay, so it's going to look like that. Again, at the point HK, if A is less than 0. So that probably makes sense to most people about that we're following. You guys understand what H and K is by now. You see what's going on. So if it's in turning point form, that's what it looks like. Okay, if it's in factorized form, then again, life is good, life is easy, life is sweet. And so what it looks like is you're going to have, you guessed it, different zeros at P, Q, R, and S, whatever they are, okay? And so it's going to come up and down and up and down. So it's got three turning points and it looks like that. So if it's in turning point form, it looks like a squished parabola. If it's not in turning point form, then it looks like this. Then you get these sort of different turning points sort of going all over the place. So P, Q, and RS. So that's if does it done it at a bit? If A is less than 0, it looks like that. So like the upside down sort of thing. If A is greater than 0, then you probably guessed already. I'll just go quickly, but it sort of would look like the opposite. So like a W more sense. So if A is greater than 0. Okay, so that's what happens there. And again, I'll put it in just in case anyone's like, what are those points? P, Q, R, and S. Okay, if it's factorized. Again, if it's in general form, then you've got a lot of work in front of you. Like quartics are pretty horrible, to be honest. If you thought cubics were horrible to factorize, to be able to get it into a form to be able to use, quartics are even harder. But the example we've got, I'm going to do today is a little bit simpler. So we'll have a look at that now. Okay, so they're the three different ones you could get. So let's have a go at sketching this guy here. Y equals x to the power 4 minus 10x squared plus 9. So what we want to do to be able to sketch this is to factorize it. As you saw here, if we can factorize it, we can see what the zeros are, the x-intercepts. Life is much easier. Could we get it into turning point form? Maybe, but we'll have to sort of see what happens with factorizing first. So let's have a look. So firstly, what you'll notice for this particular one is that there's an x4 and an x2. There's no x cubed and there's no x. And so what we could actually do here is we could do a little trick here, and I'll show you sort of the two ways, but they're the same way, but one sort of just makes probably more sense to some people than others. What we could do here is say let u or whatever equal x squared. Okay, so I'm just going to place that. So what that means is that y is equal to u squared minus 10u plus 9. Okay, so that's just replacing that, and that's changed this quartic into a quadratic. Okay, much simpler in terms of u. Okay, Can I factorize this thing? It certainly looks to me like you can, okay? Because we've got, I'll put my u here and my u there. Factors of 9, 9 and 1, I can already see that that will make negative 10. If I go minus 9, minus 1, that will make positive 9 when I multiply them, and it will sum to negative 10 when I add them. And so it's equal to that. Now I can put my u back in. So that was x squared minus 9, x squared minus 1. Okay, and that's good. So I've got that factorized down into two quadratics now. Can I go further? In fact, yes, I can. If you notice that that is equal to x squared minus 9 is actually the difference of perfect squares. So that's x minus 3, x plus 3. And x squared minus 1 is also the difference of perfect squares. So that's x minus 1, x plus 1. And so what I've got now is it's fully factorized. And that is lovely because it means it's easy to sketch. And so we can put a bunch of things in here. So what we're going to have intercepts at 3, 1, negative 1, and negative 3. Okay, because A is positive, it's going to sort of come down and end up going up. It might be helpful to get a y-intercept, so we'll just get that. So when x is equal to 0, y is equal to 9. That's nice and easy, so I'll put that on here as well. That's 9. And let's now sketch this guy. So I might come at it from this side and start up here. So it's going to sort of come down, go up like that. Oh, the first side looked good. The second side, not so much. Okay, so it's going to look a little bit like that. It's a bit wonky, but there you go. So I'll label this guy x4 minus 10 x squared plus 9. And that's how I would sketch that. So if you can factorize it, life's simple. If you can't, well, you're going to have a world of pain. But normally, if you get a quartic, like an exam or something like that, there'll be some good way of factorizing it. And so that'll be just a matter of practicing factorizations. Like we did with a cubic, you could try to guess some of those zeros in there. And if you can guess more than one, like you got 1 and negative 1, you could sort of guess those and sort of get you out of trouble, and you might be able to get down to a quadratic that you can factorize, etc., etc. But you're sort of trying to look for some clues. The shortcut that I was going to say is that you could actually go straight from there to there. Okay. And what you could sort of say is, I'll just sort of come out down here, is that you can go straight to factorizations there, because you go, well, it's going to be x squared there and x squared there, and 9 and 1 minus 9 minus 1. So you can go straight to that. If you can sort of see that, then life becomes much, much easier. So I hope that makes sense. Let's just do one more example for quartics, because like I said, the theory is virtually the same as cubics. It's sort of getting just a little bit harder. Here we go. So we've got an equation, f of x. So f of x is equal to, let's have a look. What information do we have? We have it crossing at negative 2. We have it touching at negative 1. We have it crossing at 3. And we have a y-intercept of 2. Let's put all that information into a big quartic. So we're going to have x plus 2. That takes care of it crossing at negative 2. It touches at negative 1. So it's going to be x plus 1 squared. And it crosses at 3, so it's going to be x minus 3. We don't know the dilation factor, so we chuck an a out the front, and that will be our function. Hope that makes sense. To be able to find out what that dilation factor is, we're going to sub 0, 2 in, and so we'll get, therefore, we're going to get 2 is equal to a. If x is 0, you're going to get 2, you're going to get 1 squared, and you're going to get negative 3 there. Okay. Just checking my maths there. 2 equals that 0. 2 times 1. Yep, all good. Therefore, 2 is equal to, that's just 2 times negative 3, so that's negative 6a. Therefore, a is equal to negative 1/3. Okay, so that means my function f of x is equal to negative 1/3 x plus 2, x plus 1 squared, and x minus 3. Done. If that makes sense. As you can see, very, very similar to cubics, just a little bit harder. See you in the next video.